Welcome to Study Loop.
To find the probability, here we're going to have the Max-Born normalization condition, which gives the integral over dx dy dz, which is the volume, times psi squared, right? So psi squared over the volume integral is equal to 1, where psi is equal to some constant c times the sine. So I'm using the abbreviation just s for sine, times the sine of nx pi x over L, times the sine ny pi y over L, times the sine nz pi c over L. So for given the over for integrating here. So let's go ahead and do part A. So the probability for A, P, is the integral from x equals 0 to L over 2. For Y, we're integrating from 0 to L, and from Z, going from 0 to L. Okay, and C is just a constant, so we can pull that off. Let's move this stuff over so we can pull the constant side of the integration. So we have the constant C squared, so we have C times sine and x over L times sine ny pi y, and then thing for E. Sine squared times that squared times the z value, just as above, that goes there. Okay, and again, this is an integration dy dz. Treat the integration with respect to x, y, z separately, and again, the integration is from 0 to L over 2 for x, 0 to L for y, and 0 to L for z. So we find that the probability here, so according to the Max-Born rule, of course, just this equation, if it's equal to 1, gives us a value of v equal to 2 over L, is done in the book. You can proof again if you want it. Not so when this is equal to 1, c is equal to 2 over L to the 3. Place c with 2 over L to the 3 halves. Of course, c is getting squared there. So what we have here is the probability is equal to 2 over L to the third. That's coming c being squared. Times L 4. So that's coming from nx pi x over L from 0 to L over 2. And then you have L over 2 from integrating dy, and L over from integrating to z. So if you notice, the L's cancel, and left with 1/2, 4.5 as the probability. Okay. Next, for B, the area over which we're integrating is going to change. So for B, our probability, and we have c squared that gets pulled out front. And for x, we're integrating from 2 to L over 4. For y, we are integrating from 0 to L and from 4 to L. And then that which we are integrating over stays the same. So instead of having to rewrite the entire thing, let's just put it in a green box. So this green box here is going to go down here, and it's going to be the same here. So again, just integrating with respect to x, y, and z, those values that contain x, y, and z for the sign. And so we get probability is either the first going to be the same as it comes from c, so this is to the third. The only value that's is the value with respect to x. So this time, because it goes from L over 2 to L over 4, we end up with L over 8 plus L over L divided by 4 times pi. With respect to y and z, the integration doesn't change, it's still L over 2. So bringing in values, again, cancel, and so this leaves a value of 0, 0, 9. As our solution, part B.